Hi everyone, I'm Hanuma Teja Maddali, a PhD student at the University of Maryland. My co-authors are Andrew Irlitti and Amanda Lazar. Welcome to our talk on probing the potential of extended reality to connect experts and novices in the garden. Extended reality, or XR for those of you unfamiliar, represents a continuum of technologies from augmented to virtual reality. Varying combinations of real and virtual images are overlaid on the user's field of view to alter how they perceive their environment. The HCI and CSCW community has long been interested in XR design for remote expert guidance. XR experiences are becoming increasingly immersive and interactive, so there's been a revitalized interest in XR-based systems that augment remote guidance and training for physical tasks, for example in professional settings like surgical training, field servicing, and industrial design. Even as our understanding of XR for remote collaboration in professional settings has grown, we need to note that XR devices are becoming more accessible as consumer devices for informal settings. An area to examine is how XR can support such expert-novice collaboration in informal settings as exemplified by skilled physical hobbies. The interaction needs and motivations of experts and novices can differ between professional and hobbyist settings. Hobbyists are usually more motivated by the joys of production and learning a way of life rather than an economic incentive. Hobbyist learning also differs from professional settings in the way that skill sharing takes place in settings involving family and friends, and how strictly the training is evaluated. For this paper, we chose to focus on the hobby activity of gardening. Gardening is a popular activity where learning often takes place in an informal community setting. Within HCI research, there have been calls for studying how socio-technological systems could support skill sharing in the garden, and in supporting communities when there aren't many local experienced volunteers, for example in school gardening programs. The advantages of remote XR systems over conventional video have been well studied in research on remote expert instruction for physical tasks. So there's an opportunity to understand whether XR could augment such learning experiences in informal settings, with our paper taking remote groups of gardeners as a case for a hobbyist setting. In this work, we try to understand the perceptions of practitioners regarding remote skill sharing in the garden, the kinds of interactions that could be supported in XR for novice versus expert gardeners, and the degree to which users might benefit from XR technology for collaboration in the garden. To do this, we conducted two user-centered design studies, which involved iterations of prototyping at different fidelities, as well as semi-structured interviews as part of the prototype evaluation process. For these two studies, we recruited 27 participants with varying levels of expertise who reported regularly gardening, assisting with the garden, or were experienced gardeners or novices. Participants were encouraged to involve relatives, friends, or for example, a mentor they learn gardening from as study partners. In the first study, we created two exploratory storyboards and two experience prototypes that were set in different social contexts and with one or all users working in a physical garden. We conducted 5 60-minute sessions with 11 participants. Participants performed some pre-chosen on-site tasks as a reference experience when providing feedback on the prototypes. From these sessions, we categorized the interactions between participants during the on-site sessions and in their prototype feedback into 3 types, which are instruction, observation, and discussion. In the second study, we designed 3 medium fidelity XR prototypes, each based on a popular activity for the key interactions from study 1, which is the instruction, discussion, and observation. We evaluated each prototype with an expert-novice dyad role-playing a scenario for the associated activity. One participant from the dyad acted as a remote user wearing a VR headset, and the other as the user in the garden using an AR device, which could be a tablet or a mobile, but mostly a tablet. As an example, our garden planning prototype was based on the key interaction of discussion. Here, the remote expert wearing a VR headset collaborates with an on-site novice using the AR tablet. Their scenario was to plan an empty garden plot represented by a 360 image in VR. The remote expert is provided with a virtual spade to plant virtual plants and a drawing tool that was used to draw layouts or point at areas of interest. Other prototypes also had the drawing tool and a virtual camera tool to help with the instruction or observation related scenarios. 10 expert novice dyads evaluated 3 XR prototypes in a simulated remote setting with respect to how they would normally perform the activities associated with these prototypes. We collected a combination of observation notes and 14 hours of videos of groups from both studies, and we performed a thematic analysis of this data. We followed Braun and Clark's suggested approach, starting with the familiarization with data through transcription, initial coding and identifying emerging themes, and iteratively building on these with the research team to produce the findings. Our findings cover three salient themes from the analysis. The first theme is participants' perspectives on remote gardening with XR. We see some perspectives that encouraged questions about using XR and others who are more open to the idea from the beginning. These are usually related to how participants viewed natural spaces and in-person sensory experiences with gardening. And while there was some initial hesitancy towards XR, some participants provided positive examples of remote interaction from gardens that helped others visualize possibilities for XR. For example, EA talked about enjoying FaceTiming with her mother from her garden to ask questions. We also find different views on whether XR itself needed to be the medium, since some participants felt comfortable with the computer screen, while others thought of XR as a nice leeway between regular video and being able to get feedback as if you're on site, and they were also comfortable with XR. The second salient theme from our analysis is the usability of the XR prototypes with the three key interactions we identified in study 1, which are instruction, discussion, and observation. In our paper, we presented the positives, challenges, and suggested improvements for the prototypes to be able to support these key interactions. Overall, some of the explicit merits for XR seem to be related to discussion and observational interactions. XR could augment supporting reflection and visualizing, for example, the passage of time, a specific example being visualizing how the sun moved over the plot for planning, or by using libraries of relevant 3D content during the tasks, which can act as examples for the novice. For example, how a plant might look like with pest damage. A major challenge came from the limitations on sensory engagement with the remote environment. And this affected the way that practitioners made qualitative assessments, for example, about how the soil might feel to touch. From our findings, we suggest that researchers could explore collaborative approaches between the remote and on-site user, for example, when exploring objects hands-on. We also discuss if XR can truly provide an advantage over video, and if simulating sensory information in XR for the remote user would be useful or even necessary. The final theme from our analysis is on connecting interactions and emotional dimensions during these sessions. The groups in our study consist of participants who were friends, family, or colleagues. Being able to interact with them by discussing their individual or community motivations for gardening and sharing personal experiences and stories was important for the prototypes. In study 2, participants tried connecting in XR, for example, trying to share virtual objects, as in this picture, taking selfies with the virtual camera tool, and by using the drawing tool for doodles during discussions. Errors made by novices during the gardening sessions also helped connect and learn about each other. We proposed a few design considerations for XR in informal hobby settings that can augment building what is called common ground in communication theory through these connecting interactions. This is important as it can have positive effects on trust and effective collaboration. The first is related to design approaches that can highlight familiar sounds or sights to encourage connecting with the local ecosystem, or highlight familiar objects linked to local historical and environmental context to encourage sharing experiences and stories around the same. We also discuss other considerations to augment connecting interactions in XR by allowing practitioners to meaningfully express the significance of objects in the activity space. And we discuss how supporting realism for connecting interactions might be different versus instructional interactions. Gardens are a great example of an informal hobby setting that stimulate, encourage questions, inspire, and connect people. We encourage HCI researchers to consider exploring this and other hobby activities as compelling spaces to explore design possibilities for informal XR. We invite you to read our full paper for more information.